So here's some other examples to help you. I'm really trying to hit this home because a lot of people, maybe to some of you it seems simple, but a lot of people get this very much confused and mixed up. So let's say I have two elements, element X and element Y. Maybe this could represent oxygen and this could represent hydrogen or something. These would be classified as pure substances. So this would be a pure substance, and it's an element because looking right here, I have nothing else except for that element. So it's a pure substance, specifically it's an element. Same thing here, right? Here I have nothing else but hydrogen, 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 hydrogen. So it would be a pure substance element as well. What about this? Well, I have both of them now mixed together, but should I classify this as a compound? No, because this diagram does not say anything about the fact that these are strongly bound together. There are no chemical bonds there being shown. So I cannot say it's a compound. Those elements are not compounded, stuck together to make a new substance. Rather, they're loosely mixed together. So this would be a mixture. And probably I could say it's a homogeneous mixture. It looks pretty well evenly distributed, so a mixture. This would now be a compound. I would classify as a pure substance. This is a pure substance over here, by the way. A pure substance, and that is a compound. How do I know it's a pure substance? Because I see nothing else except for this structure. And I have 1, 2, 3, 4 of them. That is it. How do I know it's a compound? Because the way that this has been drawn is implying to me that the hydrogens here have been stuck onto, have been strongly bound to the oxygen. I have water, I have H2O, 2 hydrogens, 1 oxygen. That's a compound. It's a pure substance because there's nothing else, and it's a compound. What if I was to do this? What if I were to have in here some other loose structures like this? Maybe these are hydrogen atoms that did not end up getting compounded with any oxygen. They're just loosely floating. Now what would I classify my system as? Can I still classify it as a pure substance? No, it's actually a mixture of substances. It would be a mixture of a compound and an element. So that would turn this into a mixture. I do want to take the time to remind you of something we've already discussed. We will be analyzing parts of this in more detail later, but just looking at this diagram, do you know what I'm about to bring up? Yeah, the idea of intermolecular forces. So intermolecular forces are these loose, weak, attractive forces between particles, between compounds, between molecules. These are water molecules. Remember, what is a molecule? It is a unit of bound atoms. So these dotted lines represent weak attractive forces between them, intermolecular forces, intermolecular, between molecules, attractive forces between molecules. What are these sticks representing? Those are representing another type of attractive force known as a chemical bond. So please understand the difference between intermolecular force and chemical bond. I know that we kind of already talked about that last unit. I just wanted to bring it up real quick here. How would I classify this, by the way? It's a pure substance and it's a compound, right? Because all I have are compounds of hydrogen and oxygen. So remember, we're trying now to be very careful to answer the question, what are these particles that we're talking about? Particles that make up everything, that are in constant random motion. And so far we've said, well, really the building block of everything are atoms. So here's a hydrogen atom. Are atoms, and sometimes those atoms can be stuck together in different arrangements. Here is an atom, here are atoms stuck together via chemical bonds into a molecule, into a unit of bonded atoms. Hydrogen, hydrogen, oxygen, H2O, that's a molecule. So here's my particle in this system, it's water molecules. And atoms can get stuck together in different arrangements, right? We can get ionic crystals, etc., etc. So what are particles? What are we talking about with the kinetic molecular theory that all matter is composed of small particles in constant random motion? We're talking about atoms, and then we're talking about atoms that are bonded together. we talked about how to classify matter. I would like to talk briefly about properties of matter. How can we talk about matter's characteristics or properties? Properties of matter can be broken down into two different types, physical properties or chemical properties. Physical properties are things that can be really easily observed or measured without changing the identity of the substance. So think about water. What can you analyze about water without, so remember water is this, water is hydrogen, oxygen, hydrogen. What do these dashes represent? Chemical bonds, right? Let's just say that I have a collection of water molecules just like this. What else could I draw here to make my diagram look really accurate? I could draw intermolecular forces, right? So dotted lines. What do the black bars represent? Strong chemical bonds. What do the red dotted lines represent? Weaker intermolecular forces. So this would be like a sample of water. What can I analyze about the water without changing its identity? Well, first of all, what is going to be, what would I have to do to the water to change its identity? I would have to break these bonds, right? I'd have to rip the atoms apart because then it's not going to be water anymore. If I boil the water and completely break the intermolecular forces, is it still water? Yeah, it's still H2O. It's still atoms stuck together in a specific arrangement. So physical properties are properties that can be analyzed without breaking bonds, without changing the identity of the substance. So these are things that you can just kind of directly measure very easily, things like texture, color, sometimes the taste. We can measure the density, the ability to be dissolved or to dissolve things. So we know that water can dissolve salt really easily. It can dissolve sugar, things like that. I can do that without changing its identity. Melting and boiling points. Once again, if I boil water, I'm not ripping apart the atoms. I'm not breaking the chemical bonds. That's not what I'm doing. I'm tearing apart the intermolecular forces. It's still boiled water is still water. It's just water is a gas that water in which I've broken the intermolecular forces. Right. So physical properties are these properties that can be analyzed without breaking chemical bonds, without changing the identity of the substance. Chemical properties are properties that can be only be observed or measured when the substance undergoes a chemical reaction and becomes a new substance. So that would require me to break these bonds, or to make new bonds, which we will talk about. So the ability to react with other substances, how flammable it is, oxidation. Oxidation is a process kind of like rusting. So think about rust. What do you know is capable of rusting? Iron, right? That's a chemical property. The fact that it can rust, the fact that it reacts with oxygen gas in the atmosphere and forms what we call rust. How reactive it is, how stable it is, things like that. Those are chemical